a problem from complex number. Let Z1 and Z2 be the nth root of unity which subtend a right angle at the origin. Then n must be of the form 4 options are given. We have to find the correct alternative. This is very conceptual problem. Okay, we first discuss here about the nth root of unity. Let the nth root of unity, this means 1 raised to 1 by n, this is equal to z. So z to the power n, this is equal to 1, and 1 can be written in polar form of complex number as cos 0 degree plus I sin 0 degree. Okay, and generalizing this value we get cos 2n pi plus 0 plus I sin 2n pi plus 0. That is z, this is equal to cos 2n pi, sorry, this is k and this is k, because here nth root of unity. We take k as integer in generalizing the value, or we take r as integer to generalizing the value. Let it be r, not k, because in option there are k. Okay, so we get this is 2k pi by n plus I sin 2k pi by n using de Moivre's theorem, because this to the power 1 by n, so this is 2k pi by n plus I sin 2k pi by n, where k, this is equal to 0, 1, 2 to n minus 1, and here k is 0, 1, 2 to infinity. Okay, this is the generalization of complex number, and these are the nth root of unity. This n are the nth root of unity. Now we put this nth root of unity, that is the n complex number, in complex plane. Looks like this is complex plane, and we draw a circle of radius 1. Okay, and if we take k equal to 0, then the complex number z0, this is equal to cos 0 plus I sin 0, and this complex number is here, this is z0, because this is 1 0 and this is 1, that is 1 plus I0 written as 1 0. And the second complex number, if we put this as 1, we get z1, this is cos 2 pi by n plus I sin 2 pi by n. So this 2 pi angle divided by n number of equal angle, and we put each complex number as, this is z1, this is z2, and similarly this is zn minus 1, and so on. Right, these are the nth root of unity in the circle. Now here z1 and z2 are such two complex number. Let z1 be cos 2 r1 pi by n plus I sin 2 r1 pi by n, and z2 is cos 2 r2 pi by n plus I sin 2 r2 pi by n. These two complex number, and it is says that which subtend a right angle at the origin. Let this is z1 and this is z2. Okay, and subtend a right angle means this angle is right angle. If this is z1 and this is z2, and this line z1 z2 makes right angle at the origin, this is pi by 2. And if z1 of the form cos theta plus I sin theta, then z2 must be of the form cos pi by 2 plus theta plus I sin pi by 2 plus theta, because the angle is pi by 2 between them. So this complex number is this is sin theta plus I cos theta, this is minus, and we get this is I into cos theta plus I sin theta. Because we put here minus 1 is I square, and taking common I, this is cos theta plus I sin theta written here. Now we see that Z1 by Z2, this is equal to 1 by I, so this is minus I. Clear? And we say that if Z1 Z2 subtend a right angle at the origin, then Z1 by Z2 must be purely imaginary. Purely imaginary. Okay, this is very important result for further use. Okay, this is fixed in your mind. If Z1 Z2 subtend the right angle at the origin, then Z1 by Z2 is purely imaginary. Now come back to our main problem. Here Z1 by Z2, this is given by cos 2 R1 minus R2 into pi by n plus I sin 2 R1 minus R2 into pi by n. And here we use De Moivre's theorem, because quotient of two complex number is given by a complex number of the form cos theta plus I sin theta, but angle are subtracted. Okay, we subtract this from the upper angle and we get the result directly. Now this must be purely imaginary or imaginary only if this term must be 0. This term must be 0. That is cos 2 into R1 minus R2 into pi by n, this is equal to 0. So this must be cos pi by 2, and this result gives this angle are same. That is, we get 4 into R1 minus R2 and pi cancel out, this is equal to n. Here R1 and R2 are two integer from here. Any two integer from here 0 to n minus 1, and R1 minus R2 is also an integer of the form k, and 4 multiply here 4 into k, so n must be of 4n. So we have to find the correct option. N must be of the form, this is 4n. Okay, the option D is correct, and this is very important and conceptual problem of complex number. Thank you for watching.